Honestly, being able to enjoy pre-made meals should be credited to pre-stressing. In 1907, the father of pre-stressing in France used a jack to create the longest span prefabricated bridge in the world at that time, to address the cracking caused by concrete creep and shrinkage. However, while both prefabricated structures and pre-made meals face constant controversy, pre-stressed bridges receive widespread acclaim. Today, let's explore whether this widespread acclaim is well-deserved or if there is any cutting of corners involved. The first step in creating pre-stressed structures is to activate the conveyor switch, which uses rollers to move the wire rod forward. The rebar is then rolled into the required square shape along a predetermined track. The shapes of the frameworks are varied and diverse, so relying on just one type is insufficient. Therefore, on the other side, large threaded steel bars are also being rolled simultaneously. It will be used for installation, providing the main lateral support. Compared to the previous type, it appears thicker in size, and its strength is exponentially increased. Now we move on to the second step, which is assembling the framework. Observant individuals might notice that the placement of the stirrups is very tight. But this tightness is not due to randomly placing the rebar. The margin of error in spacing is generally no more than 3 centimeters. After all the binding wires are wrapped, the craftsman takes out a crowbar, inserts it into the rebar cage, and forcefully lifts the main rebar, then places the smaller stirrups on top. This ensures that the thickest rebar in the middle always remains in the same position. Then, all the connection points are tightened. As the bridge framework takes shape, the mold is cleaned. First, a layer of release agent, also known as a separator, is sprayed along the surface. It creates a protective film between the mold and the concrete, making disassembly easier and the surface smoother. Next, the framework partition is placed in the middle to fix and prevent the rebar membrane from sinking due to excessive weight. At this point, the mold is formed and the rebar cage is hoisted. At this time, the cage has been reinforced with many steel strands by the workers. Judging by the density, there are no fewer than 10 strands, each with a diameter of approximately 15.2 millimeters. These are ultra-strong strands, with a tensile strength grade of 1860 MPa. Does anyone recognize if this is the type of steel strand? Then, insert the steel pipe into both ends of the stirrup, and use a horizontal hoist to slowly lift one side, Next, take the air gun and tighten all the screws on both sides, ensuring that the stirrup remains at the same level. Now, move to one side to start reinforcing the steel strands. First, place the 2 metal halves into the outer ring. Then fully insert the exposed end with fibers. The more you pull this fixture, the tighter it gets. But to achieve even greater tension, the hydraulic device in front is indispensable, as the master inserts it. Once he reaches the exit end, the machine will continuously pull outward using hydraulic pressure. The steel strands also change at a visibly noticeable speed. So, do you think that's it? Clearly, it's not enough. To increase the connection strength on both sides of the bridge, several finger-thick rebar pieces are inserted at both ends of the mold to reduce wear from vibrations on the bridge. Then, each rebar is placed into fixed gaps. Cement blocks are added between the rebars, and wire mesh is threaded through the rebars before everything is tightened uniformly. Every step is done so meticulously, without a single mistake. Especially the next step. Can you believe the master is adjusting the rebar inside with a hook? Now we enter the next step of preparation before pouring. The master picked up 2 rubbers that look like hourglasses, and they are all inserted into the rebar cage. Does anyone know what this is for? Now let's start pouring. Located above, there is a large amount of prepared concrete in the tank. During this period, no manual operation is required, and the equipment will automatically complete the work according to the program. Then take out the vibrating rod and start manual vibration, which will form countless bubbles on the surface after vibration. Bubbles are the culprit that affects the concrete structure. They are the interlayers that appear during the pouring process. Only when all the bubbles disappear can we enter the maintenance stage. But before we start, we need to carry a spray bottle and spray a layer of clean water, ensuring that the cement surface is completely covered with water. This helps prevent the surface from drying out too quickly. Then, while the concrete is resting for a moment, we cut off the excess parts to prevent them from being too long on both sides during the lowering process, which could cause breakage. Start the steam curing process by lifting the cast piece. Compared to natural curing, steam curing takes much less time. It solidifies and takes shape in just a few hours. Next, we prepare to move on to the next step, where the master lights up a torch and starts cutting off the connections at one end of the steel strands. This cutting method looks really fast. In less than a minute, all the steel strands have been removed. Once the excess parts are cleaned up, we can move on to the final step of this round, demolding. Everyone can see that the surface of the concrete comes off very easily during the demolding process, with almost no adhesion at all. Now, let's talk about the technique used in this round, called the pre-embedding method. The so-called pre-embedding means that the rebar is embedded in advance to fully amplify the strength of the steel structure before pouring, and it differs from the thickening method only in terms of process, with no significant difference in strength. At this point, the rectangular pre-stressed bridge has taken shape. Do you know how many tons this big guy weighs?